Hello guys, welcome in today's session. I am Professor Fayyaz Kawadi from Department of Mechanical Engineering. In today's session, we are going to study angle relationship for function generation and analytical synthesis of four-bar mechanism, which is also known as Frudenstine equation, from unit number 5, synthesis of mechanism from theory of machine subject. In front of you, you can see the figure of four-bar mechanism in which you can see the input link AB of four-bar mechanism. It is called as input link because you are giving the motion to that link. The another end of that link is connected to the next link BC, and then another end of link BC is connected to the next link CD. As you give the motion and it start rotating in anti-clockwise direction, that motion is transferred to link CD. That's why that link CD is called as output link, in which you will get the required motion. For example, oscillatory motion or a rotary motion. Okay, that link CD is getting motion from link AB through the link BC. That's why it is called as intermediate link or it is called as coupler. Link AD is fixed link or it is called as frame. Now link AB is making angle theta with fixed link AD. At the same time, link CD is making angle phi with fixed link AD. Okay. Now, the initial position of the link AB is AB1. AB1. So, at that time, the starting theta at that time AB1 is making angle theta starting. Theta S is denoted theta starting. And as it is start rotating and it will take the new position as AB2, at that time it is making angle theta final, which is denoted here theta F, theta final. So theta final minus theta starting will become here delta theta, delta theta. At the same time, the output link CD is making angle phi when the initial position of input link AB1, at that time simultaneously output link CD is making the new position C1D, DC1. At that time it will making angle phi starting with the fixed link phi starting, and when the input link is taking new position AB2, at the same time the output link is taking new position DC2, and inclination of DC2 is phi final. So phi final minus phi starting will become here delta phi, delta. Okay. Now come to the next point. This four-bar mechanism is used to generate the function y is equal to f of x over the limited range of delta theta, delta phi, delta x, and delta y. So delta theta is equal to theta phi minus theta s starting. At the same time, delta phi, which is the inclination of output link with fixed link, is equal to phi final minus phi starting. Okay. Now the relationship between x and theta and similarly y and phi is plot, you will get the linear relationship of inclination with respect to precision points. If I plot the location of precision points on x-axis and on y-axis, I will plot the inclination of input link. I will find the linear relationship of inclination of output link with respect to precision points. So when first initial precision point x starting, at that time I will get theta starting. So as the precision points, location of precision point is goes on changing, the theta is also goes on changing from theta starting to theta phi. This will become the range. This likewise for output link, if on y-axis, on x-axis, I will plot the precision points from y starting to y final. At that time, I will find the relationship, a linear relationship of precision point with respect to inclination of output link phi. Okay, when y is starting, at that time the it will make the angle phi starting with fixed link. At the same time y final, y final, yeah, I will get at that time theta final. So a linear relationship I will get with a precision point with respect to the inclination of output link with the fixed link. Okay, so from this graph I can conclude that theta, delta theta divided by delta x, delta theta, this will become delta x and this will become delta theta. That is zero position, delta 0 to del x phi, x final minus 0 to x starting. So this will become delta theta, sorry, this will delta final, theta final minus theta starting. So this much distance will become delta theta and this distance will become delta x. So delta theta divided by delta x is equal to theta final minus theta starting divided by x final minus x starting. Okay, now we have to find out theta at final position, theta final. So what I do here, I will take the cross multiplication. So theta final is equal to delta theta divided by delta x. I will move that term to left side. Okay, delta theta by delta x into xf minus xs, xf minus xf, I will move to left side, so it will become multiplied to this term, and this minus theta s, when it will move to left it will become plus, plus theta s. Okay, so theta at j position, theta at first position or second position or third position, if you have to find out three precision point, so theta at j position will become, formula will become here, theta j is equal to delta theta divided by delta x into xj. If it will second position, theta at second position, the x will become here second position x2, or theta at third position, third precision point, it will become x3. Okay, x at j minus xs starting plus theta starting. So remember this formula while solving the numericals. Okay, theta final or theta at j is equal to delta theta divided by delta x into x at j minus x starting plus theta starting. Similarly, for output link, the same formula can be written as phi j. Phi is the inclination of output link. Inclination of output link for j position is equal to delta phi divided by delta y into y at j position, y j minus y starting plus this theta will be replaced by inclination of output link, that is phi s. So remember these two formulas for solving the numericals, that theta is for input link and that phi is for output link. Now come to the next topic, the analytical synthesis of four-bar mechanism, which is also known as Frudenstine's equation. Remember in previous session we studied the Chebyshev spacing method to find out the Chebyshev spacing method to find out the precision points, and Frudenstine equation is used to find out length of linkages in four-bar mechanism. Chebyshev spacing method is used to find out the precision points, whereas Frudenstine equation is used to find out length of linkages in four-bar mechanism. So consider a four-bar mechanism ABCD as shown in figure, which have lengths A, B, C and D respectively. See, link AD is fixed. Link AD is fixed. Link AB is input link. Link BC is coupler or connecting link or intermediate link. Link CD is output link. Okay. Length of input link AB is shown here by small a. Length of intermediate link BC is denoted by small p. Length of output link CD, capital CD, is denoted by small c, and length of fixed link is denoted by small d. That deviation may come in the examination. Okay, the four-bar mechanism, capital A, B, C, D, and length of each link is small a, small b, small c, and small d respectively. At the same time, link AB is making angle theta with fixed link AD. Link BC, link BC is making angle beta with fixed link AD. Output link CD is making angle phi with fixed link, okay, and AD is not making angle as it is a horizontal link. As it is a fixed link, it is not making angle. As it is fixed link, it is not moving, so it is not making angle. It is making angle 0 with fixed link or with x-axis. Okay. Now these linkages I will consider as a vector. Okay, this link A, B, C, D I will consider as a vector. So vector is a having magnitude as well as direction also. Okay, so magnitude of link AB is small a, magnitude of vector BC is small b, magnitude of vector CD is small c, and magnitude of vector AD is small d. Also by arrow I am showing here the direction of this vector. Okay, AB, B to C is the direction of vector BC, C to D is the direction in downward direction, and D to A is shown the direction from D to A. Okay. Now next thing, this A is making angle theta with the fixed length. So I will take the component of A in x direction and in y direction. Okay, so I will draw the dotted line from point B, which is perpendicular to x. Okay, this is the vertical component of A, and this x-axis will become horizontal component of A. So the vertical component, as you learn in mechanics, the vertical component of A is become A sine theta in this triangle A, B, and this vertical line. In this triangle, A is hypotenuse and this vector is making angle theta with horizontal axis x. So this vertical component will become A sine theta and the horizontal component will become here A cos theta. A sine theta and A cos theta. Okay, and direction of this component will be as well the resultant is moving A to B. So this vertical component will move from bottom to top and this horizontal component will move A towards right. So this will become resultant will move up to B. Okay, now the second thing, the vector BC is moving B to C. So I will make, I will take the component of B in vertical direction and in horizontal direction along x-axis and along y-axis. So I will draw the dotted line from B, which is perpendicular to x, and from this B point, capital B point, I will draw the horizontal line which is parallel to x. Okay, and I will form this triangle BC and this vertical triangle, this triangle. Now I will take again the horizontal and vertical component of this vector. So vertical component will become B sine beta, this beta and this length. Okay, B sine beta, and the direction will move from bottom to top as it is moving from B to C. B to C. So the component will move from bottom to top and the magnitude of that component will be B sine beta, and the horizontal component will become B cos beta, B cos beta from this triangle, and the direction of this vector will be from B towards right. Okay, now third component, which is output length, is C, and the magnitude is small c, and the direction of that C is from C to D. So I will form the triangle here. From C I will draw the perpendicular line, and from this I will draw the horizontal line which is parallel along x-axis. So I will get the triangle here D, C, and this vertical point D, C, and this triangle. In this triangle, this is 90-degree. So I will take the vertical and horizontal component of C. So vertical component will become here C sine phi. Okay, C is making angle phi with the horizontal axis x. So this vertical component will become C sine phi, and the direction of vector C is from C to capital D, capital C to capital D. So that vertical component is moving downward direction, C sine phi, and the horizontal component of C will become here C cos phi, but the direction is from right to left, C cos phi. Now next link is link DA, but that DA link is fixed and along axis, so there is no inclination, so there is no vertical component also, only horizontal component. You can see here AD is small d and towards D to A from right to left. So if this figure is clear to you, then we will go to the next step. Now what I do here for equilibrium of the mechanism, mechanism, the sum of components along x-axis and y-axis must be 0. So along x-axis, I will take the all components along x-axis. This is x-axis. So a right side component which is moving towards the right, I will take positive, and left side component I will take negative. Okay. So a cos theta, a cos theta plus, this is horizontal component, b cos beta, b cos beta minus c cos phi minus d. These all are the components along x-axis. Along x-axis. So a cos theta plus a cos theta plus b cos beta minus c cos phi minus d is equal to 0. Is equal to 0. A cos theta plus b cos beta minus c cos phi minus d is equal to 0. Now I will take the vertical components of all the linkages, all the vectors. Vertical component is upward direction I will take positive, and downward direction I will take negative. Okay. A cos theta along y-axis, vertical component, plus b sin beta, again it is a plus, minus c sin phi. Why? It is going downward, so I will take minus c sin phi, and vertical component of d is no, so it will become 0. So a sin theta plus b sin beta minus c sin phi is equal to 0. Is equal to 0. This will become equation number 2. A sin theta plus b sin beta minus c sin phi is equal to 0. There is no component along y direction for d, so it won't come in this equation. From equation 1 we can write equation 1. This will equation 1. We can write b cos beta. Remaining all terms I will move towards the right. Okay, b cos beta is equal to, b cos beta is equal to this d minus d, it will become here plus d minus this term, a cos theta minus c cos phi. Okay, this complete I will take in bracket, and this plus bracket will become here minus bracket, minus a cos theta minus c cos phi. This will become equation number 3 from equation number 1. Same wise, I will b sin beta I will put on left side, and all the terms I will move towards right. So plus b sin beta is equal to minus in bracket a sin theta minus c sin phi. A sin theta minus c sin phi I will take into that bracket, and this plus bracket will become here minus bracket, minus a sin theta minus c sin phi. This will become equation number 4. Now squaring the equation number 3 and squaring the equation number 4 and adding with each other. Squaring and adding addition of equation 3 and 4. First I will square, and then I will make addition of equation number 3 and 4. It will become here b square plus cos square beta plus b square into sin square beta. Okay, squaring of this term and squaring of this term and addition, b square cos square beta plus b square sin square beta, okay, is equal to squaring this term, this complete term, d square, this minus minus will become plus of whole bracket. You know, in trigonometry we learn a minus b bracket square. or a plus b bracket square is equal to a square plus b square plus 2ab, or a minus b is bracket square is equal to a square plus b square minus 2ab. The same, I am doing expansion of this term, d minus this complete term square plus this complete term plus squaring of this term. Okay, so plus into bracket square bracket minus a sine theta minus c sine phi bracket square, squaring both the term. So I am getting here sine square theta plus cos square theta is equal to 1. Sine square beta plus cos square beta, I will take b square as common. B square is equal to 1 into 1 by sine square beta plus cos square beta is equal to 1. Okay, now expansion of this term, squaring this term. So a minus b square, so a square minus 2ab minus plus b square, so d square minus 2ad cos theta, okay, minus 2ad a cos theta minus 2 into d and into this term a cos theta minus c cos phi plus this squaring this term a cos theta minus c cos phi bracket square. This will become expansion of this term a minus b bracket square. Now squaring this term, second term, plus this minus minus will become plus here, squaring of minus minus plus a sine theta plus c sine phi square. Okay, square. Now next thing, b square is equal to d square minus 2ad cos theta, and this minus minus will become plus 2cd cos phi. Okay, multiplication of minus 2d to this term into bracket minus 2ad cos theta, and this minus minus will become plus 2cd cos phi, and plus squaring of this bracket a minus b bracket square a square plus b square minus 2ab. So squaring of this a square cos square theta minus 2ac cos theta cos phi plus this minus minus will become plus c square cos square phi, c square cos square phi. Now squaring of this bracket, will become a square sine square theta minus 2ac a and this c 2ac sine theta sine phi, and this minus minus will become plus here plus c square sine square phi. Don't make mistake in giving sign to the terms in examination also. Now the next step is b square d square, in this a square cos square theta and a square sine square theta. I will take a square from this term common, and sine square theta plus cos square theta, it will become 1. Same as this in green color, c square cos square phi and plus c square sine square phi. I will take c square common from this term, which I shown here by green color. And next is 2ac cos theta cos phi, and here minus 2ac sine theta sine phi. From this term I will take 2ac common, which I shown in purple color. Okay, I again simplify this b square is equal to a square. This will become 1 sin square theta plus cos square theta. It will become 1. Okay. Plus this c square and this c square I will take common, and again sin square phi plus cos square phi, it will become 1. Okay. Plus d square, a square plus c square plus d square, and from this term this d square, d square, this d square minus 2ad cos theta, okay, plus 2cd, 2cd cos phi, 2cd cos phi, and this minus 2ac and minus 2ac I will take common, minus 2ac cos theta. Now cos theta cos phi plus sin theta sin phi, okay, cos a cos b plus sin a sin b. What is that? That will become cos a minus b. So cos theta minus phi. Okay, I explain again this step. B square is equal to d square, this d square as it is, d square. From these two terms I will take a square common, and this will become 1 sin square theta plus cos square theta. So, and from these two terms I will take c square as common, c square, and this will become sin square phi plus cos square phi, it will become 1. Okay, minus 2ad cos theta plus 2cd cos phi, and from these two terms I will take minus 2ac common, minus 2ac. So remaining will be cos theta cos phi plus sin theta sin phi. Okay, so what is cos a cos b plus sin a sin b? This will become cos a minus b. So cos theta minus phi. So again rearranging the term, b square is equal to a square plus c square plus d square minus 2d minus 2ad cos theta plus 2cd cos phi minus 2ac cos theta minus phi. Now this term I will take a right side, and b I will take a right side, and this term I will move towards left side. So this minus will become plus 2ac cos theta minus phi a square. This will move right, so it will become minus a square minus b square plus c square plus d square minus 2ad cos theta plus 2cd cos phi. Now I will divide that whole equation by 2ac, 2ac, or I will move that 2ac towards the right. So it will become cos theta minus phi, cos theta minus phi. Divide that term by 2ac, so it will get cancelled, and a square plus c square plus d square minus b square divided by this 2ac minus this 2 and 2 will get cancelled, a and a will get cancelled. So d divided by c, d divided by that c into cos theta plus this 2 and this 2 will get cancelled. This c and this c will get cancelled. This a will move towards right. So d by a cos phi. Okay, d by a into cos phi. Now cos theta plus phi is equal to this this dA, DC, and this ABCD. These all are the length of linkages. Okay, so length of linkages is not goes on changing, so it will become fixed parameter, so it is constant. So for d by a, for this constant I am taking k1 as constant, k1 cos phi. For d by c, for this constant I will take k2 as constant minus k2 cos theta, and for this whole term constant I am using k3. So k1 k1 cos phi minus k2 cos theta plus k3, this will call as Frudenstine equation. The above equation is called Frudenstine equation. Cos of difference of angle of input link minus output link is equal to k1 cos of output link minus k2 cos of input link plus k3 will become here Frudenstine equation. So value of K1 will become B by A, which is length of output link divided by length of input link. K1 is equal to length of output link divided by length of input link, where K2 is length of output link divided by intermediate link, okay, plus K3. So K1 is equal to B by A, okay. D is fixed link divided by input link, where K2 is fixed link divided by output link, and K3 is equal to squaring of input link A square minus intermediate link plus output link plus square of fixed link divided by 2AC. Okay, so this is about finding the length of all the linkages with help of Frudenstine equation. Remember this equation for solving the numerical. Cos theta minus phi is equal to k1 cos phi minus k2 cos theta, where phi is inclination of output link with respect to fixed link, and cos theta, theta is inclination of input link with respect to fixed link plus k3. Okay, so at the end of this session, student can understood the angle relationship for function generation and Frudenstine equation to find length of linkages in 4-bar mechanism. Thank you for observing this video or watching this video.